welcome back. In this video, we are going to practice using the combined gas law. And what's nice about the combined gas law is that we can solve for any variable as long as we're given all of the others. So let's read the question. It says, a balloon has a pressure of 2.3 atmospheres and a volume of 0.4 liters at a temperature of 298 Kelvin. If the pressure changes to 3 atmospheres and the volume changes to 0.3 liters, what is the new temperature? The first thing we're going to do is write out everything that we know. Our P1 is 2.3, V1 0.4, T1 298, and it's nice that it's already in Kelvin. If it wasn't, we would have to switch that. P2 is equal to 3, and V2 is equal to 0.3. And we do not know what T2 is. So we need to rearrange our formula to solve for T2. So the first thing I'm going to do is multiply it to the other side. So I have T2 times P1 V1 over T1 equals P2 V2. And then we just want to get T2 by itself, so I'll multiply my T1 over to the other side. And then the last thing that I want to do is divide by P1 V1 so that my T2 is left by itself. So I have T2 equals P2 V2 T1 over P1 V1. The last thing I need to do is just plug my numbers in. That's the easy part. So T2 is equal to pressure 2 times volume 2. So 3 atm times 0.3 liters times our T1, which was 298 K, over P1 times V1, so 2.3 times 0.4. And let's make sure our units cancel. Atmospheres, atmospheres, liters, liters. We're left with Kelvin, which is what we want. And if we put that into our calculator, we get 292 Kelvin. So our temperature decreased by 6 Kelvin. If rearranging the formula and solving for variables is hard for you because of the quotient, one thing that you can do to start out, and you can just always write the law this way if you need to, is P1 V1 T2 equals P2 V2 T1. And all that I did is I just multiplied my T's over to the other side to get rid of that quotient. So if that's easier for you, you can write your combined gas law this way so that no matter what you're solving for, so if I was solving for V1, well, that just means I'm going to put P1 and T2 on the other side. If I'm solving for T2, that means I'm just going to put P1 V1 on the other side. So that just helps if you don't like fractions and you want to simplify rearranging your formula. Don't forget, temperature does have to be in Kelvin. So if you're given Celsius, you need to add 273. If you're still struggling with gas laws, make sure and check out my channel. Thank you so much for stopping by.